Well, now it's time to look at all this from the compiler's point of view and ask what it is able to determine, because that's really what controls these typing and subtyping areas. So let's assume that we're given that we've got this generic type GN of this type parameter T extending I and J and K, and X and Y are as shown on this diagram here, where just to make a point, you can have more than one path through this hierarchy of types leading connecting these two. Just in case you hadn't considered that as a possibility, it is a possibility. So the question is, what can the compiler tell with certainty? And I'm assuming that X and Y are different, of course. Well, it can tell with certainty that the set of all types which extend X is going to contain the set of all types that extend Y. And also it can tell that the set of all types which are super X is contained in the set of all types which are super Y. And this holds no matter what the rest of this hierarchy in here does. And therefore it follows that if you intersect these things with a set of all types which extend I and J and K, then you can say, when you look at these things as sets of allowable types, you can say that Gn of something which extends X contains or is equal to the Gn of something which extends Y. And similarly for the super case, it's the other way around, of course. We're looking at these things as sets of allowed types of the form Gn of some type Z or something. Okay, sort of allowed Z, that is. So now you might say, well, why are we allowing the possibility of it being equal? Well, because we're intersecting it with some other set, a set of all types that extend I, J and K, and so they could end up being equal. Okay, so given an interface or class, what else can we say? All of its super types can be determined by the compiler, because it just goes and looks at the thing that says class something or other, extends something or other, and implements something or other. So it can follow all that tree up without any problems. But what it cannot do is determine the subtypes, because it doesn't know that you've not written another class somewhere in some other part of your file system hidden away which extends the class that it's looking at. So it can't determine subtypes, but it can determine supertypes. Now, what else can we say? If Y is both final and it is not a subtype of I and J and K, then we can say with certainty, if it's both final and it's not a subtype of that, then we can say that Gn of something that extends Y is not going to have any allowable types in that set. You can't say G of Z where Z is something or other and set it to that. It won't allow anything. And that's why it will give an error, a compiler error, when you try and write something like that down. And in a similar sort of way, if X is not a subtype of I and J and K, then Gn of something which is super X similarly is not going to allow any types at all. And so in exactly the same sort of way, that will also give a compiler error. Okay, that should be fairly obvious.